Hey everyone, Dr. Shaikh here from The Dentalist. Welcome back to another video on dental material science. Today we're covering chapter 9, which is casting from Applied Dental Material Science by McCabe. Casting is one of the most crucial processes in dentistry. It's what allows us to fabricate metal restorations like crowns, bridges, and denture frameworks with precision and accuracy. Without casting, we wouldn't have the strong, durable restorations that patients rely on every day. But casting is not as simple as melting some metal and pouring it into a mold. It's a highly technical process. And even small errors can lead to casting defects, just like how we discussed in the previous video. So in this video, we'll break it down step by step, explaining the lost wax technique, investment materials, common defects, and troubleshooting methods. Let's get started. Casting is the process of shaping a molten material by pouring it into a mold where it solidifies into the desired form. In dentistry, this technique is widely used to manufacture metal crowns, inlays, onlays, partial denture frameworks, and other fixed prostheses. But why is casting so important? It allows customized metal restorations tailored to each patient. It ensures a precise fit and high durability. It is cost-effective and widely used in dental labs worldwide. The accuracy of the casting process is critical. Even a slight discrepancy in the final restoration can lead to poor fit, discomfort, or failure of the prosthesis. This is why we rely on a well-established technique known as the lost wax technique. Now, I've discussed about the lost wax technique in one of my previous videos, but we'll go through this again. Lost wax technique has been the gold standard in dental casting for decades. This process allows us to create extremely accurate metal restorations by first making a wax model of the final restoration. Why do you think we use wax, by the way? Because wax can be precisely shaped and then completely eliminated, leaving a cavity into which we can cast the metal. Let's go through each step so that you can understand the lost wax technique properly. So the first step in lost wax technique is wax pattern creation. A detailed wax model of the restoration is made directly on the die to replicate the final shape accurately. Now the next step is sprueing. A sprue, a small wax rod, which is attached to the wax pattern, creating a channel for molten metal to flow. Then the next step is investing. The entire wax pattern and sprue are enclosed in a casting ring filled with a heat-resistant material called investment material. Then there's the burnout phase. The mold is heated to eliminate the wax, leaving a cavity in its exact shape. The temperature must be carefully controlled to ensure complete wax removal. The next stage is casting. Molten metal is forced into the mold cavity using either centrifugal casting or vacuum pressure casting. And then the next stage is cooling and recovery. The metal solidifies and the investment material is broken away to reveal the final restoration. Then there's finishing and polishing stage, in which the excess material is removed, the restoration is polished, and the final shape of the restoration is achieved. After the final shape is achieved, the fit and shine of the restoration is also checked. Each step plays a crucial role in ensuring that the final metal restoration is accurate, strong, and defect-free. Now let's talk about the investment materials that are used in this process of casting. The investment material is basically what creates the mold for the metal casting. The choice of investment material is crucial because it affects the final accuracy and surface quality of the restoration. Broadly, there are three main types of investment materials used in dental casting, each designed for different type of metal alloys. The first type of investment material is gypsum bonded investment, which is used for casting gold alloys with melting temperatures below 1200 degrees. It consists of silica and calcium sulfate, which provide thermal expansion. The next type of investment material is phosphate bonded investment material, which is designed for casting base metal alloys like cobalt chromium and nickel chromium, which require high temperature resistance. And then the third type is silica bonded investment materials, which are used for high fusing alloys and removable partial denture frameworks. Each type has specific thermal expansion properties, ensuring that the final casting compensates for shrinkage and maintains accuracy. Now let's talk about the common casting defects and their causes. Despite our best efforts, casting defects can still occur. These defects compromise the fit, strength, and aesthetics of the final restoration. Let's go through some of the most common defects, their causes, and how we can prevent them. We've covered this in the last video as well, but I just wanted to go through it again so that you can grasp this knowledge and get a better understanding. So the first one is porosity, which was gas entrapment or shrinkage of the metal during solidification. Prevention is to ensure proper temperature control is taken care of and the use of proper degassing techniques. Then the next defect is incomplete casting. The metal does not completely fill the mold, often due to incomplete wax elimination or improper metal flow. The prevention for this defect is to use a proper spruing design and ensure adequate burnout. So the third type of casting defect is rough surface, which is caused by the investment breakdown or contamination of the mold. The prevention for this is to use high quality investment material and ensure a clean working environment. The fourth defect is fins and spines. It is caused by the cracks in the investment mold that allows metal to seep through it. Prevention is to properly handle the investment material and control the expansion. By understanding and preventing these defects, we can ensure that our cast restorations are high quality, durable, and precise. Now let's talk about modern advancements in casting. While traditional casting methods are still widely used, modern digital technologies are transforming the way we fabricate metal restorations. Two of the most exciting advancements are CAD/CAM, which is computer-aided design and manufacturing. Digital impressions and milling techniques allow for faster, more accurate restorations with minimal manual intervention. And then there's direct metal laser sintering, 3D printing technology that creates metal restorations but layer by layer, eliminating the need for traditional casting altogether. While these technologies offer incredible benefits, casting remains a widely used and cost-effective technique for many dental restorations. To wrap up, casting is a cornerstone of dental materials science. We should understand this process properly. So today we covered the lost wax technique and its step-by-step process, the role of investment materials and their impact on casting accuracy, and then the common casting defects again and how to prevent them, and the modern advancements in metal restoration technology that you should be aware about. Understanding these principles will help you make better clinical decisions and improve the quality of your restorations. I have designed a quiz on casting specially for you, so make sure you find that link in the description below and take that quiz. If you found this helpful, hit the like button, subscribe, and turn on the notifications so you don't miss any future videos from me. See you in the next one. Take care till we meet again.